Welcome everyone. Through this video, today I will discuss the topic of probability, that is conditional probability. It is included in class 12 board exam and also in competitive examination. Today I will discuss only the basic concept. Basic concept. So what is conditional probability? Probability of an event A when B has probability of an event A when B has already occurred. When B has already occurred is denoted by P A by B and defined as P A by B equals to probability of A when B has already occurred equals to probability of A equals to number of favorable cases. Favorable cases of A as well as B by number of favorable cases of B. Number of favorable cases of A as well as B when B has already occurred. Number of favorable cases of A as well as in B by number of favorable cases of B. So, n of A intersection B. N number of elements, cardinal number of A as well as in B, that is intersection, by NB. Now, if we divide it by sample space N A union B by total number of elements in NS, NB by NS. So, it is by definition PA intersection B, classical definition, by PB. So, this is our definition. Probability of an event A when B has already occurred, given B has already occurred, is denoted by PA by B and defined as denoted by PA by B and defined as P A by B equals to probability of A when B has already occurred. So, number of favorable cases of A as well as in B by number of favorable cases of B. So, number of favor N A intersection B by N B dividing by NS, this is P A intersection B by PB. So, this is our basic concept. So, P A by B. You have to recall this formula. P A by B equals to P A intersection B by PB. Similarly, PB by A also. Probability of B when A intersection B or B intersection by PA. Probability of B when A has already occurred. Now, property. Properties. So, some basic properties. P A bar by B equals to 1 minus B A by B. P A bar by B equals to this. Proof. So proof is not required. Look for your interest. P S by B. S by B. S is sample space. Equals to P S intersection B by PB. Now you know P S intersection B. So by property of set, it is the smallest set. This is PB by PB equals to 1. So PS by B equals to 1. Now PS by B, we can write it as, what is S? PS intersection B by PS intersection B by PB. So we have already proved this is as 1. Now what is S? S equals to A union A dashed by B equals to P by definition B intersection A union A dashed by BD. Look, property of set. So if it is A dash but A bar, then A plus A bar equals to S. So for S, you can write this. So from definition of conditional probability, now from distributive law, B intersection A union B intersection A dashed by PB. So this is PB intersection A plus PB intersection A dashed B intersection A and B intersection A dashed. Suppose this is B. So B intersection A is this and B intersection A dashed is this one. They are disjoint. So we can write it as PA union B equals to PA plus PB. Now this P B intersection A dashed. So PB intersection A by PB plus this is the lower set, least set, PB intersection A dash by PB by PB intersection A dash by PB. Now look, from definition PB intersection B by PB, this is P A by B, and this is P A dash by B. P, so this is not visible, so this is P A by B, this is P A dash by B. P A dash by B. Now this one P S by B equals to 1. This is P S by B equals to this. So left hand side is 1. So finally what we are getting, you look, this is 1. So P A dash by B equals to 1 minus P A by B. So this is proof. So no need of proof, you remember it. So listen again. P A dash by B 1 minus P A by B. Now to prove this result, we use this one. P S by B. S is a sample space. S intersection B by PB. So this is the list set. This is S intersection B is B. PB by PB equals to 1. So what is S? A union A dash by B unchanged. Now from definition of conditional probability P, B intersection this. Use distributive law. So B intersection A union this. These two sets are exclusive. So we can write it as PA plus PB by PB, dividing it into two parts. So this is P A by B, this is A dash by B, and left hand side this is PS by B, this is 1. So P A dash by B 1 minus P A by B. So this is proof of the result. Now one more result. P A union B by C, P A by C plus P B by C minus P A intersection B by C. So no need of proof, but look, proof is very simple. So LHS, P A union B by C. From definition of conditional probability, denominator is PC. So this is PC intersection A union B. Now PC intersection numerator. So use distributive law. C intersection A union C intersection B by PC. Now this is PC intersection A plus PC intersection B by property, addition property of probability, minus P C intersection A intersection C intersection B by PC. Now this is PC intersection A by PC. Make it into three parts. C intersection B by PC. And this is PC. So C intersection C is again C. So C intersection A intersection B. So this is PA by C. This is PB by C. This is PA intersection B by C. So this is proof of the result. So what is conditional probability and two important property. So now we solve some simple problems of conditional probability, 1 or 2 marks problems. Now I consider two problems. So most important problem for board as well as WBJE also. So very simple problem. So problem number 1. A and B are two events associated with a random experiment. PA equals to 1 by 3, PB 1 by 4, PA intersection B is given. Find PA by B, A dash by B, PA dash intersection B dash. So problem number 1. So P A by B. So this is the simplest one from definition. A intersection B by PB. If it is by B, then PB. So this is 1 by 5. 1 by 5, and what is PB? 1 by 4. So this is 4 by 5. So simplest problem, 1 marks problem. Now second one, P A dash by B. So by the earlier definition, this is 1 minus P A by B. So 1 minus 4 by 5. This is 1 by 5. 1 minus P A by B by above theory. Now P A dash by B dash. By definition, this is P A dash intersection B dash by PB dash. Now, if you know, if both are in terms of complement, we use De Morgan's law. So this is P A union B total dash. A union B total dash equals to A dash intersection B dash. So this is P B dash or PB, same symbol. Now this is 1 minus P A union B. This is 1 minus PB. So P A union B, this is not given, so we have to calculate it. So 1 minus P A plus PB minus P A intersection B by 1 minus PB. So putting this value, so 1 minus, what is PA? 1 by 3, PB 1 by 4, this is minus 1 by 5. So 1 minus 1 by 4. So calculating, we get result. So this type of problem are most important for both and WB JEE. Now you calculate it, problem number 2. Exactly same problem. So PA, PB and PA union B equals to given. But for conditional probability, we need the intersection 1. So PA union B equals to PA plus PB minus PA intersection B. So this implies 0.8, this is 0.5, this is 0.6 PA intersection B. So what is PA intersection B? So 0.3. 11, 1.1 minus 8. Now this is exactly same that of earlier. So P A dash by B equals to 1 minus P A by B. So 1 minus P A intersection B by PB. So 1 minus, what is A intersection B? 0.3. And this one is PB. PB is 0.6. So 1 minus half equals to half. So P A dash by B. Now finally P B dash by A dash. Number 2. P B bar by A bar. So P A bar, this is B bar by A bar equals to P B bar intersection A bar by P of A bar. So this is by De Morgan's law. Both are in complement. So A union B total complement by P A complement. So this is 1 minus P A union B, 1 minus P A. So what is A union B? It is given 0.8. 1 minus 0.5. So this is 0.2 by 0.5. So 2 by 5. 2 by 5. 0.2, 0.5, so 2 by 5. So use definition of conditional probability, and we also need idea of set. This is most important for solving problem of probability. You need idea of distributive law, associative law, De Morgan's law. These properties are most important. Now we solve some language problem, practical problem. Now we consider two simple problems. Today I will consider only simple problems. So problem number 3. A dice roll. If the outcome is even number, if it is given even number, then what is the probability that it is prime number? So this is 1 marks problem. So S 1, 2, 3, 4, 5, 6. 4. 1, 2, 3, 4, 5, 6. 6 possible outcomes. A equals to even that outcome is prime. So 2, 3, 5. 2 is a prime, 3 is a 5, 5 is a B. It is given that outcome is even. Even that outcome is even. So 2, 4 and 6. Now it is given that outcome is even number. You have to find that probability of finding that it is also a prime number. So required probability. So look, what is the probability that it is prime number? So A, it is taken as prime number, and it is given that outcome is even number. So required probability is PA by B. You have to find PA by B. A, what is the probability that it is prime? So it is A. Given is at the denominator. So it is PA intersection B by PB. So what is PB? PB 3 by 6. This is 3 by 6. And what is common? A intersection B. Set A intersection B, common is 2 only. 2 is only common. So this is 1 by 6. So finally we are getting 1 by 3. So answer is 1 by 3. So it is simplest one. So this is S even. So this is probability that it is prime. B equals to even that it is even. So required probability. Probability that it is prime. So P A by B. So answer is 1 by 3. And now second one. So very simple problem we are considering today. Now problem number 4. A coin is tossed twice. So what is sample space? HH, HT, TH and TT. This is sample space. E equals to both heads, both head and tail. So E equals to both head and tail. So head, tail, head. And F equals to at most one tail. At most. Maximum one tail. So this is HT, TH, one tail. So maximum one tail or no tail also, that is HH. So these to be noted. At most one tail or no tail. So P, E intersection F. So what is common? HT and TH. These two are common. Now PE by F equals to, from definition, PE intersection F by PF. So what is E intersection F? 2 by 6. 2 by 6. PF. This is 3 by 6. So this is 2 by 3. 2 by 6. This is. And P, F intersection, F by E. So P, F intersection E by PE. So F intersection E, we have already calculated it. This is 2 by, these are 4. This is, S is 4. So 2 by 4, 3 by 4. So this is 2 by 4. And what is PE? PE, this is 1 and 2. So 2 favorable cases, 2 by 4. So this is 1. So this is 2 by 4. Common element 2, this is also 2 by 4. So F 1, 2, 3, 3 by 4. And this is for E 2 by 4. So we are getting PE by F and PF by E. So these are very simple problem. Now I consider one more simple problem. Problem number 5. A couple has 2 children. Find the probability that both children are boys. If it is known that condition is imposed here, at least one of them is boy, at least one of them is a girl, older child is a boy. So 2 children. So what is sample space? Both are boys, girls. Both are girls. So this is our sample space. Now find the probability that both children are boy. So A equals to both children are boy. So it is BB only. And for case 1, B equals to at least one of them is boy. At least one of them is boy. So BG, GB, one boy and 2 boy. At least. Number C, at least one of them is a girl. So GB, BG and GG also. One girl, 2 girl. And number 4, D, older child is a boy. Older child is a boy. So older child is a boy. So suppose older, first one. So this is BB. It is possible. Older child is a boy. BG is a also possible. ZB is not possible. So G first, here also G first. So these are the subsets. Now we have to find this probability. Both are boys. Both are boys. A, under the assumption that number 1, P A by B, at least one of them is boy. So this equals to P A intersection B by P B. Now what is A intersection B? A intersection B. So B B is common. Only B B is common. So 1 by 4. And what is PB? 1, 2, 3, 4. Sorry, PB 1, 2, 3. So 3 by 4. So this is 1 by 3. 1 by 3. So listen again. Find the probability that both children are boy. Both children are boy A under the assumption that at least one of them is boy. P A intersection B. So which one is common? B B. So this is 1 by 4. This is 3 by 4. Now second one. P A by C. Two children are boys under the assumption that at least one of them is a girl. So P A intersection C by P C. So this is C. So 2 by 3 by 4. And what is A intersection C? Common of A and C. Common of A and C. Only BB. So no one is common. So this is 0 by 4. So this is 0. This one is 0. So at least one of them is girl. There is no common element in A and C. So third one, P A by D. Both are children under the assumption that older child is a boy. So P A intersection D by P D. So P D, this is 2 by 4. 2 by 4. Older is a boy. So what is common of A and D? So BB and BG. Older, sorry, A. A is BB. A is BB. So BB is common. So this is 1 by 4. So finally we are getting half. So probability is half. So through this video today I will consider some simple basic problems of conditional probability. From the next class, I will take 3 more classes on conditional probability. I will go from basic to moderate, then to difficult. So, thank you for today.